Бүгінгі қорғауда үш тілде сөйлеулеріңізге болады. Қазақ тілінде, орыс тілінде, ағылшын тілінде. Түсінбеген сұрақтарыңыз болса, аудару болады. Уважаемые коллеги, можете говорить на русском, на казахском, на английском языке. Будет перевод. Good morning, dear colleagues. On the basis of the orders of the rector of Гумилев, Eurasian National University, number 1060-, dated November 1st, 2024, and November, number 11-NK, dated January 8th, 2026, amendments and additions were made to the previous order on the establishment and approval on the composition of the dissertation council in the field of personal training, AD 053 Chemical and Physical Sciences in the specialty, 6D 060600 Chemistry in the educational program, AD 05306 Chemistry, with the following permanent composition. Permanent members of the dissertation council. I am the chair of the dissertation council. Искак Важана Пахтыбаевна, director of the Research Institute of New Chemical Technologies of LN Гумилев, ENU, candidate of Chemical Sciences, Professor Astana, Republic of Kazakhstan. Ибраевои, Professor of the Department of Chemistry of LN Гумилев, ENU, Doctor of Chemical Sciences, Professor Astana, Republic of Kazakhstan. Deputy Chair. Машан Тобжан Тургаликызы, Professor of the Department of Chemistry of LN Гумилев, ENU, Candidate of Chemical Sciences, Professor Astana, Republic of Kazakhstan, Scientific Secretary. Караков Илья Владимирович, Republican State International Enterprise on the right of Economic Management Institute of Nuclear Physics of the Ministry of Energy of the Republic of Kazakhstan, PhD Associate Professor Astana, Republic of Kazakhstan. During the defense, recording will be carried out. Therefore, it is not allowed to turn off the camera, leave during the defense, get distracted, or communicate with third parties. The video recording must clearly show that is you, who are participating in the work of the dissertation council. Dear members of the dissertation council, at the meeting of the Dissertation Council dated March 26, 2026, Protocol number 28, the following persons were approved as temporary members of the Dissertation Council for the defense of the dissertation by the candidate Ибраевои Аягоз Каи. Allow me to introduce the temporary members of the Dissertation Council. Mulay Rashid Baba, Associate Professor of the Department of Chemistry, Engineering and Material Science, New Uzbekistan University, PhD Associate Professor, Tashkent, Republic of Uzbekistan. Машинцева Анастасия Александровна, Head of the Technological Laboratory of Track Membranes of the Astana branch of the Institute of Nuclear Physics, PhD Professor, Astana, Republic of Kazakhstan. Нурбекова Маржан Абдыжаппаровна, Acting Associate Professor of the Department of Chemistry of Kazakh National Women's Pedagogical University, Candidate of Chemical Sciences, Almaty, Republic of Kazakhstan. The following official reviewers have been appointed for this dissertation. First reviewer, Dr. Jixibek, Professor of the Department of Chemistry of Abay, Kazakh National Pedagogical University, PhD, Professor Almaty, Republic of Kazakhstan. Toxtarbay Jeksenbek is present. The second reviewer, Najibkızı Mervet, Professor of the Department of Chemical Physics and Material Science of Al-Farabi Kazakh National University, Chemical Sciences, Republic of Kazakhstan. Najibkızı Mervet, according to the attendance list, 7 members of the Dissertation Council and 2 official reviewers are present at the meeting. According to the standard regulations on the Dissertation Council of the Ministry of Sciences and Higher Education of the Republic of Kazakhstan and the regulation on the Dissertation Council of the in the field of personal training, AD 053, Chemical and Physical Sciences Specialty, 6D 060600 Chemistry, Educational Program, AD 05306 Chemistry. The goal as of May 13, 2026 is present. The meeting of the Dissertation Council is held in a mixed format. There is a proposal to begin the work of the Council. Any objections? No objections. The meeting of the Dissertation Council is declared open. Everyone has the agenda. Defense of the dissertation for the degree of Doctor of Philosophy by Ибраевои Аягоз Каи on the topic Design of Highly Effective Novel Electrolytes for Photovoltaic Application, the specialty 805-306 Chemistry. The dissertation is presented. The dissertation was completed at the Department of Chemistry of LM. The dissertation research is presented the first time. Scientific consultants, concerning the work of the research, associate professor of the Department of Chemistry of LM, PhD Astana, Republic of Kazakhstan. Scientific consult for the lecture of the School of Science and Technology, University of New England, DND, and Bay, Australia. Are there any comments from the members of the Dissertation Council on the agenda? No comments. The agenda is approved. For familiarization with the personal file on the candidate, the floor is given to the Scientific Secretary of the Dissertation Council, Chemical Sciences, Professor Toğcan Turgalikızı Maşan. Toğcan Turgalikızı, please, you have the floor.
Thank you. Yeah, members. Thank you, dear members of the Dissertation Council. Please allow me to present the material submitted to the Dissertation Council in the field of training of personal physical and chemical science education program by the candidate Ибраевои Аягоз Каи. She was born on July 20, 1992 in the city of Satpaev, Karaganda region, Republic of Kazakhstan. In 2014, she graduated from Buketov Karaganda State University with a bachelor's degree in chemical technology of inorganic substances and in 2016, she obtained a master's degree in chemistry from the same university. From 2021 to 2024, she pursued her doctoral studies in the specialty chemistry at the Gumilev Eurasian National University. During her doctoral training, she completed a research internship at Nazarbayev University in the Department of Chemistry, where she worked in the research group of Professor Manix Balanay. Her total professional experience exceeds 12 years. At present, she is a researcher at the Laboratory of Renewable Energy at the Center for Energy and Advanced Material Science of the National Laboratory Astana, where she conducts research in the field of alternative energy resources and the development of synthesis of materials for sustainable energy technologies. The following documents have been submitted to the Dissertation Council. First, recommendation letters from the domestic and foreign scientific supervisors certified at their respective place of employment. Second, minutes of the extended meeting of the Department of Chemistry containing a positive conclusion and a recommendation for defense approved by the member of the board, Vice Rector for Science, Commercialization and Internationalization of the Gumilev Eurasian National University. Third, the dissertation manuscript in the form of a series of published articles in form and electronic media. List of scientific publications signed by Secretary of the Board, Academic Secretary of the Gumilev Eurasian National University, and the copies thereof. Fifth, the conclusion of the Committee for Ethical Evaluation of Dissertation Research of the Gumilev Eurasian National University, confirming the absence of violations in the planning, evaluation, selection, conduct, and the dissemination of research results, including the protection of the rights, safety, and the well-being of research subjects. Six, official transcript confirming completion of the doctoral educational program. Seventh, a personal record sheet certified of the place of employment. Eighth, a certificate confirming the availability of publications in scientific journals indexed in the international databases of Web of Science, Core Collection, and the Scopus issued by the branch of the National Center of Science and Technology Evolution. In total, the candidate has published 3 papers on the topic of the dissertation work in the first quartile and the second quartile journals with a non-zero impact factor according to Web of Science, Core Collection, and the Scopus database. Materials today, energy, scientific reports, molecules. Also on patent for utility model of the Republic of Kazakhstan and several presentations and international scientific conference. In addition, within the time frames established by the standard regulations, the following documents were submitted to the Dissertation Council. Ninth, a certificate from the National Center of Science and Technology Evolution confirming that the matches were identified because of similarity analysis with its database. Tenth, reviews from the official reviewers submitted no later than 5 working days prior to the defense. The submitted materials comply with the requirements of the standard regulation on Dissertation Council of the Ministry of Science and the Higher Education of the Republic of Kazakhstan, as well as the regulations of the Dissertation Council of the Gumilev Eurasian University in the field of training of personnel, physical and chemical sciences, educational program chemistry. The candidate Ибраевои Аягоз Каи is admitted to the defense. Thank you.
Thank you to Ибраевои. The submitted personal files and documents fully comply with the requirements. Are there any questions regarding the personal file? If there are no questions and everything complies with the requirements. To present the main content on the dissertation research, the floor is given to the candidate Ибраевои Аягоз Каи. The time limit is 20 minutes. Please adhere to the time limit.
Members of the Dissertation Council. Today I am pleased to present my doctoral research entitled Design of Highly Effective Novel Electrolytes for Photovoltaic Application. My scientific supervisor is Dr. Ибраевои, Dr. Robert O'Reilly. According to the statistical review for the energy for 2025, we can see that fossil fuels still the main source of the electricity, which is because greenhouse gas emissions, environmental serious problems. That's why we need to shift to renewable energy. Here on the graphs, you can see that renewable energy source has over advantages. Fossil fuels, particularly low carbon emission, sustainably and economically and environmental benefits. As we can see, the amount of other renewable energy sources, solar has a big potential, which is hits our Earth 173 terawatts continuously. And this photovoltaic technology then developed photovoltaic technology. Here is the three generation of them. In the first generation, we used mono and polycrystalline silicons. In second generation, we used amorphous silicon, cadmium telluride, and another selenite solar cells. Today, we are in the third generation, as there is a organic diced solar cell and concentrated another hybrid techniques. My research focus in the diced solar cell. So the research objective is to design and characterize electrolyte materials to enhance the stability and performance of diced solar cell. To achieve this aim, we evaluated several tasks. First of all, it is a synthesis of new porous materials like POF and MOF, also carbazole-based compounds like ultrasonic materials. And we conduct detailed physical-chemical characterization of these synthesized materials. Third one, optimize additive presentation of liquid electrolytes. And the last one is fabricate diced solar cell with liquid, quasi-solid, and solid-state electrolytes and test their photovoltaic performance. And main provisions are made for the defense. It has been demonstrated that incorporation of NIL-135 electrolyte enhance the power conversion efficiency from the 9.14 to 10.51. Also caused by the short course current density from the 18 to 20. And also by the electrochemical properties, it is reduced charge transfer resistance from the 1.70 to 1.99, increased ionic conductivity from the 3.02 to the 3.36. Also, it is has a good stability for the 60 days and works very well under dimmed light. In the second, we has established that creating laser shots work as an additive into the liquid electrolytes and can be able to enhance power conversion efficiency from the 8.87 to 10.81. Also improved by the short course current density. And here we can say that also we can be able to reduce charge transfer resistance, enhance ionic conductivity, and diffusion. Also, these devices was tested for 3 days and tested under dimmed light. As the last year, we evaluated by review article different carbazole and its derivatives, and saying that it has big potential to use as a whole transporting materials for the electronic devices. You can see the general working principle of diced solar cells. Here, here are 4 main steps. When sunlight hits the molecules of the dye, the electrons get excited from the ground state, the excited state. And through conduction part of titanium dioxide, which is a photoanode, electrons transfer to the counter side, which is a platinum. Then, meanwhile, oxidized dye reduced by the redox species, which is the iodide and triiodide. Triiodide ions reduced on the surface of the cathode material, platinum, and this cycle will continuously repeat. As you can see on the working principle of diced solar cell, liquid electrolyte interacts with all parts as counter electrodes and photoanodes. That's why it is important to improve their performance to avoid the leakage and evaporation. According to the physical state composition and And formation, we can divide electrolytes into three broad type. It is liquid, solid state, and quasi-solid state electrolytes, and 11 kinds. In our research, we used some additives, which is given here: butyl-methyl imidazoline iodide, guanine cyanide, and terputylpyridine to enhance not only photovoltaic performance, also to suppress recombination and surface passivation. For the first provision, we work with metal organic frameworks, which formed by the metal ions and organic linkers. It has unique, excellent properties such as large surface area, tunable porosity. We can control also pore volume. Thanks for these excellent properties, it is widely used in solar cell as a scaffold in absorber layer. In the below graphs, we can see that manganese, magnesium, aluminium with a trimesic acid MOFs already was applied as a quasi-solid electrolytes. And our research focused on the titanium MOF electrolytes, which outperform by efficiency other MOFs. Further, I will deeply go to this MOF, and by the one-step solver thermal method, we synthesize the titanium MOF. It gives to us white powder with a yield 7.75. It is terephthalic acid was dissolved in DMF and methanol. Then we added titanium isopropoxide, and at 100 degrees for 35 hours, we obtain this product. The local activation states of this framework was obtained by the XPS surveys analysis. Here we deconvoluted H elements and can see that titanium 4+ ions successfully incorporated to the framework. The morphology of this material was investigated by the scanning electron microscopy and transmission electron microscopy, also ADS elemental mapping. By the morphology, we can say that it has cake-like morphology with a particle size 750 to 900 nanometers. To obtain the crystallinity of this powder, we provided XRD. There is no additional absence. There is no additional peaks. What say to us that our synthesized MOF is pure. And by XRD, we see that it has a quasi-cubic hexagonal structure. And the main functional organic groups of this MOF was investigated by FTIR analysis. Here we can see the hydroxylic group and carboxylic groups, asymmetric and symmetric. And fingerprint region was 800 till 1200. And to know the thermostability of this material, we provided thermogravimetric analysis. Here we can see 4 stages of decomposition. In the first and second stages, it is evaporated gas molecules, solvents. Then on the third stages, it is decomposited organic liquors, which is a benzonated carboxylic. And in the last, it is inorganic salt, titanium dioxide. To know the porosity of this material, we provided a porosimetry analysis. It gives to us information that it is type 1 micropoles, and VET was 1212, and pore volume 0.61. And further, after successful synthesis of this material, we fabricate the solar cell. Briefly, we clean our FTO glasses, then apply blocking layers, then by the Dr. Blading technique, applied mesopole scattering layers of titanium paste. After that, photoanos was worked on the die for the 24 hours. After that, assembled with the platinum counter electrode and injected electrolytes. All devices were fabricated in identical condition. And for reproducibility, we always do 9 cells. Here you can see how it looks in our laboratory. We prepare quasi-solid electrolyte in the vials under dark and by continuously stirring. And here how solar cells looked. On the table, we provided also optimization work to find the best amount of this MOF material, and it was 10 milligrams. Then for the electrochemical analysis, we provided TAFL and Yaya's cell analysis. by the exchange current density, we can say that in case of quasi-solid electrolyte, electron flow was faster on the counter electrode and electrolyte interface in case of quasi-solid electrolyte. On the dummy analysis, the lower charge transfer resistance confirmation, they obtained tougher results. Also, ionic conductivity, we calculated ionic conductivity, and it was higher, 3.36 in case of quasi-solid electrolyte. To obtain, we provided EIS analysis under that condition. Here we can see the series system, and the recombination resistance was 2 times lower, which is good. It means it suppresses recombination. Further, for evaluate this, we do VOC open pulsate voltage decay analysis, which confirms this data. From the VOC decay analysis, we calculated electron lifetime, and electron lifetime was lower in case of quasi-solid electrolyte, which means it is electrons transfer fast and give us high photovoltaic performance. And here you can see the photovoltaic performance of the fabricated devices under dim light, under LED lamp. It is a 1,000, 3,000, 6,000 lux, and in all cases, quasi-solid electrolytes was higher than just liquid electrolyte. On the table, we collect the same another electrolytes and show that our prepared electrolytes works well. And for stability test, we provided for the 50 days, and by the graphs we can see that we can able to improve the stability of these devices. And also these devices were investigated under one-sun illumination. On the graph, the first photovoltaic performance was the first day, and in the graphs you can see that VOC increases after 60 days, field factor still stable, and the overall efficiency of these devices decreased because of short current density. After this video, we shift to the pure organic, which is the organic framework materials. The other name is composed polymer organic. And here there is no metal ions influence. It is has stability, removed from the video. Stability should be high, and thanks for this unique properties, it's widely used nowadays. And for this, we synthesize it, shift-based, shows the shift-based reaction, transient-based off through melamine and terephthaldehyde in the presence of DMSO for a day under 180 degrees, and we obtain bright yellow powder with the yield 64%. To the local oxidation state of this material, we provided XPS and deconvoluted, and we can see the formation of these covalent bondings. By the morphology was done by same time with this analysis. Here we can see that it has spherical morphology and particle size below 50 nanometers. Further, on the XRD, we see one broad peak, which gives to us information that it has an amorphous nature. And by FTIR analysis was evaluated the main functional groups in this framework. It is NH, CH, and CO functional groups. And further, we investigated TGA, thermostability of this material. Here there is a 3 stages of the decomposition. First of all, it will evaporate gas molecules, physical absorbed waters. In the second, organic liqueurs start to decomposite. After 445 degrees, this material fully decomposited. To know the surface porosity of this material, we provided nitrogen absorption desorption analysis. It's this classification that it has types isotherm without minimal hysteresis, and it has a megapore porous nature. BET was 612 and pore volume was 0.6. And here you can see the images how we prepare quasi-solid electrolyte and fabricate solar cells in our laboratory. Also in the table we provided optimized work, and by highlighted yellow color, 10 milligrams works well in our case. If we increase the amount of pore, it gives to us viscosity, particle aggregation, and so this. That's why we choose 10 milligrams. To know the charge transfer kinetics of these devices, we provide a temporal analysis. Here, current exchange density was higher in case of quasi-solid electrolyte, which further confirms in the dummy cell analysis, where we can see that charge transfer resistance was lower in case of quasi-solid electrolyte. Also, we provided YAIS analysis in the dark condition. And here we can see that recombination resistance was lower. Then investigated by both key analysis and calculated electron lifetime. These devices were investigated under LED lamp at 6,000 watts, and we can see that when we add pore, it is give to us more efficiency, 25.74, peaked at 27.7. While liquid electrolyte showed to us 23 efficiency. The stability test provided for the 200 hours. Then this device also investigated under one-cell illumination. On the table, you can see the photovoltaic performance of these devices, and also efficiency was higher in case of liquid electrolyte and cold. As the stability test provided for the 40 days, here work was a little bit higher in case of quasi-solid electrolyte. Fill factor was stable, and short course current density decreased by the time, which is a cause overall degradation of devices. For the third provision, after the completing quasi-solid electrolytes, we shift to the solid-state electrolytes. Here, solar cells fabricated by differently one. Instead of liquid electrolyte, we have cold transporting materials. And as a counter electrode, here we used silver. And today, as a most popular cold transport material is spiromedak, which is has a good photovoltaic. But the problem is here that it is complicated synthesis and expensive. That's why we offer carbazole, which having advantages such as electron-rich, tunable energy levels, good thermal and chemical stability it has, and we can easily synthesize another carbazole derivatives. For this aim, we provide some synthesis. On this, we access the synthetic code for the HTM1 and HTM2. First of all, we provided a halogenation of this carbazole. We put at 3 and 6 position iodine and obtain product number 1 with a 97% yield. After that, we put protection group as a tosyl for the NH group. Then further synthesized HTM number 1 through Ullmann cross coupling using copper catalysis and obtain product with the 79% yield. After that, we remove the protection group, which is a tosyl, and obtain the 79% of yield. After that, we put nitrobenzene groups in position to extend the electron withdrawing and improve this HTM. It is a HTM2 with a 79%. In the end, conclusion, I would like to say that in case of when we add TMOF, power conversion efficiency increased from the 9.14 to the 10.51, which is a 15% of improvement. Short current density also reached 20.97, which comparatively was 18. It is a 16% of increase, and the stability of quasi-solid electrolyte was 2.8 times more stable. And also we established the record power conversion efficiency for these devices, which is at 27.6%, under 6,000 lux. And these quasi-solid electrolytes show to us better retention. Quasi-solid electrolytes show to us higher ionic conductivity, reduced charge transfer resistance, and improved exchange current density. In the second, when we add both materials with electrolyte, we can be able to improve general efficiency from the 8.87 to 10.81, and improved. It is a 22% of improvement, which and JSCA was improved from the 18.16 to the from the 15 to the 18, and also it works very well under dimmed light condition. And these quasi-solid electrolytes retained 95% of initial after 40 days. And this, when we add coffee, it is helped to us increase activity, reduce charge transfer, and improved diffusion. And the last thing that by the review article, we reviewed several carbazole-based derivatives and established the structure and properties relationship between these materials, and say that it has a big potential to use in photovoltaic performance. And further here you can see the list of publication. Hof-based work was published in the Materials to the Energy Impact Factor 8.6. Second, Hof-based work was published in Scientific Report Journals. Impact Factor is 3.9. Last review article was published in Molecules. Impact Factor is 4.2. Also, we can be able to obtain one utility model of Republic of Kazakhstan for the research for the liquid electrolyte and coke-based devices. Also, during the PhD, attended several international scientific conferences and presented by oral and poster session. Here, this research was provided in the Laboratory of Functional Materials and Computational Chemistry. Group leader is Professor Mike Osman, and the funding was from the Science Committee and Ministry of Education, Higher Education and Science of Republic of Kazakhstan, also CRP programs at Nazarbayev University. Thank you for your attention.
Thank you, Aягоз Каи. The report is finished. We will now proceed to questions from council members and the audience. Please.
First of all, I would like to thank you for this nice presentation and for so very high-level results presented to me. And I have several questions about your presentation. And first of all, at the last slide, number 23, please. Did you synthesize these compounds in your work? Where is the results of its characterization, like in previous 2 chapters of your presentation? I mean that some instrumental analysis. Why you did not present it here?
Thank you for your valuable question. I have L1. It is in the back side of presentation. If you allow, I can show it to you.
Because this third part looks like not finished. You presented 2 first chapters of your presentation in wide scale observation of your results, but here just 1 slide. It's not. It's really difficult to understand what's the novelty here. You did not confirm anything in this chapter. Please, if you have some additional slides, present it.
Thank you. Let me. Here you can see the. No, it's not that. This is like shortly images from our laboratory, how we synthesize it and fabricate solar cells. And here we actually will work not only with the carbazole-based derivative, also we're able to synthesize 3 phenylamine-based compounds. and there is a for HTM. And here you can see the enema structure for each compound. This is enema structure for the 3,6-D-iodocarbazole. And next it is second compound, D-iodotosylcarbazole. Further it is D-carbazylyl tosylcarbazole enema spectra, and also we have a D-carbazylyl carbazole. First product, and the last product is D-carbazylyl nitrophenyl carbazole. For the time limited, I just put them to the back side, and
Did you test the properties of these new compounds?
yeah, here we actually started to work on them, but for now we cannot establish proper design for them. Currently, we are working on it now.
In this case, if you decided to put these results in your presentation, normally it should be finished. You couldn't tell that it's not finished, we're working on it, because it's your defense. And I think it's should be improved and should be presented again. It's not allowed, sorry. Now, a question related, why you decided to choose meal 125 more? What's the main reason to select this?
Good question. We choose it because it is has big porosity, bed analysis, and it was attractive to us because it helps to absorb more iodine species and improve the stability and efficiency of these devices, that's the solar cell devices.
And one of the main properties of any substances in energy is its stability. Test the stability of your compounds.
Yeah, here, thank you for your question. By the graphs, we check the stability test of these devices. In case of TMOF, we investigate for the 60 days, which is the 1,400 hours. And when we add titanium MOF, it works very well and prevent leakage, evaporation, and other problems what just liquid electrolyte faced. This is this is under one sample information. And also we provided a test under lead level at 6,000 lux.
And the last questions, it's always asking most frequent question on defense, and then the PhD student develop something new. What about economical cost of your compounds? Is it reasonable compared to commercial methods? Did you calculate it?
No, we didn't calculate the economical reliability of these devices. Just we want to improve, our goal was improve efficiency and stability of these devices, which we can confirm by successfully published articles. And in general, most and COF-based materials are easy to synthesize. They are not so complicated. By only one-step analysis, we can obtain powders which have high crystallinity, and it is not in general like expensive materials. For the synthesis of materials,
For the future, please take in for your consideration, because sometimes journal asking this improvement comparable with increasing the properties. Okay, thank you so much.
Thank you for your question.
Anastasia Alexandrovna, are you satisfied with the answer?
I'm still think that the first question related not finished third part, it's very critical issue for this test.
Thank you. Please.
Thank you very much for interesting work, and I have some questions. First questions, so you synthesize some carbazole derivatives, yes? And how you purify?
Thank you for your time. Verify?
Purify.
Purify by column chromatography. Some of them was obtained as a powder, no need to do column chromatography, just by crystallization. And the last steps was provided with the column chromatography in the DCM and GXN evaluation system. Difluoromethan was a polar solvent, and XN is non-polar. It's a non-polar solvent. It was
Which solvent? Which solvent?
Solvent. Which
Solvent.
solvent?
solvent.
Yeah.
Solvent. Adsorbent.
Absorbent. Silicon.
Okay. So is it new compounds?
No, they are already known compounds. They was used in OLED. We will try to do it in the it's a HTM materials for the dye-sensitized solar cell.
It's not new compounds. I think no need show all spectroscopy. No need.
No, I
Because
mean,
it's novel.
that they talking about new materials for energy. And the first two chapters was explained very well. But for the first chapter, as you can see from presentation, it's just only one slide in basic base part. And it was not confirmed the electrochemicals. It was not finished like the previous two chapters.
It's kind of additional
Okay,
work.
it's my
Which
opinion.
additional work, kind of.
Sorry, can
Yes, you can add something.
I more maybe. According to the third provision, actually we published a review article. I wanna say about review article, and for the practicing something to show that we also can synthesize. I put that synthesis roles. Also, we not only synthesize HTM, we also synthesize dyes on basis of carbazole. It was a huge work, but still the complicated of the organic synthesis we cannot done fully, cannot complete. That's why we published a review article where and this review was good because for the last 10-15 years, no one like from researchers reviewed about carbazole for the kids.
Okay, I understand. Okay, thank you. And second question, so have you studied before like these novel electrolytes for photocatalytic applications?
No, in case of cost material, it was first time applied as electrolyte additives. It was only one research where people applied in the perovskite solar cell. It is comparatively new materials for the researchers. That's why we try to work on it and successfully synthesize, apply, and all devices.
Okay, thank you.
Yes, I see the answer.
Oh, I have another one question here.
Please.
So you used MOF MIL-125, which is a titanium-based MOF, right? And what's the difference you work with the other MOF-based solar cells? For instance, what if you use copper-based MOF or silver-based MOF instead of the titanium one? What's the difference?
From the literature data, we know, like on the graph I showed that only aluminum, magnesium, and manganese MOF was applied, and they have also polymers in contains of that quasi-solid electrolytes. So in our case, we just simply mix titanium MOF with the liquid electrolyte and can improve the efficiency and stability. We don't need the additional polymer, and was like innovative. By simple mixing, we can get more efficiency and stable devices. It was our novelty.
Okay, so you said the other models, for instance, as you mentioned, it's magnesium or aluminum ones, they need extra chemicals like polymers, right?
Yeah.
Okay, that makes sense. And so my second question is probably your page 13 or the other page. If you used less amount of MOF, your performance is higher. For instance, 10 milligram or microgram, whatever there is higher.
Mhm.
If you increase the MOF, it's your performance decreased.
Yeah.
So can you page 13 or 13? 13. The concentration of MOF you used to, no, not this one.
Yeah, see,
The concentration of, the influence of MOF concentration. Yeah, you used 10, 20, and 30 milligrams or milliliter. Oh, yeah, here, this one, the MOF. Say if you increase the concentration of MOF, your performance decreased. The highest was 10. And my question, what if you used 5 instead of 10? It would be more increased, or 8, or for instance.
when we add only 5 milligrams of it, was still the properties of just liquid electrolyte. We add to more to give chance to more work as a scaffold, as a framework, and prevent leakage by the improving the amount of this powder. Performance is decreased. That's why we choose 10 milligram as the best one, and further work with this device.
Okay, the less amount of MOF is less efficient.
5 milligrams was still liquid. There will not so much properties of electrolytes.
Okay. Okay, my next question is you use this iodide and iodide 3 for the dye-sensitized also, right? And what if you used, for instance, it's also bromide ions, what if you used other than the iodide?
There is another research was developed with another halogens. But the problem with that halogenides, they cannot work with the most range of the dye. The advantages of this iodine-based liquid electrolytes, it can compete or match with wide range of the dye. There was iodine takes a broad application instead of just instead of other halogens like bromide and cyanide and other.
Yeah, that's all from me.
Thank you for your questions.
Dr. Bajicidiak, are you satisfied with the answer?
Yeah, that's correct. Yeah, that's fine.
Thank you. Please.
Thank you for a nice presentation and nice work. I have some technical questions. In slide 9, number 9. Here in XPS spectra of carbon on 1s, CC bond, could it be also CH bond? So your molecule also CH bonds, right?
We they can value this each by the energies. Let's see. By we
So
since this MOF material is already obtained, we just compare with literature data to know the clarity and purity of the structure. And for that cases, it will be enough to us obtain CC, O, and C double bonded oxygen bonds, which is a confirmation of the obtained of like this framework organic linkers.
Okay, understand. Another questions. You told us that particle size is in the range, but did you measure? Did you calculate the average size of these particles, of these MOFs?
We by the also by the microscopy analysis, we see from the different sides of this powder, and decided to it would be better if we mention that range between 750 and 9. Like bigger one was 900, less one was 750.
Okay. Next slide, please. from BT analysis. What model did you use for the calculation of average pore size, pore volume?
In pore facilities at Nazarbayev University, we give to our powders to engineers, and they send to us ready analysis. And this PET data was in TXT format, already calculated by the equipment. We just plot the relative pressure of this material.
Okay, so not all parameters is shown here in the slide. For example, pore size, it's also main parameters. You just tell us that it micropores.
Yeah, like briefly.
Okay, okay. Another question on slide 20. I'm sorry, 12. This slide, yes. It's a liquid electrode, right? Is it important for your work to study how your MOFs, how your materials is stable in the liquid? What's the average size in the liquid? Before that, you studied in a powder form, but here you use it in a liquid. And did you study, for example, DLS analysis or something?
Here, liquid electrolyte suffers from the leakage and evaporation. That's why it decreased overall the performance of devices. That's why we are looking for the materials which help to liquid electrolyte. The scaffold, framework to prevent this leakage and evaporation and do a long that this device can be worked for during for the long-term durability. This was our main goal. That's why we are from the just liquid electrolyte, we go to the quasi-salt electrolytes. And these architectures of the when we add MOF or COF, it gives to us quasi-salt electrolytes properties, and by the analysis, electrochemical analysis, and photovoltaic performance, we can see that it's really helps to us to prevent the leakage and improves the long-term stability of these devices.
Okay, I understand. Thank you. Another question, please. One or two questions. Is it important to control the force of compressions of this electrode? I see from the slides that you use splits.
It is when we assemble two electrodes, we use double-sided tape, then clip it to prevent any leakage, because when it is liquid, it is easy like leak or evaporate, because we fabricate, then put on the fridge for soaking for the prevent this. Then next day only read these devices. Also, we can use instead of clips glue gun, and by the visually we can see that electrolytes inside of these devices.
Okay, thank you. That's the last question. Slide number 18. In your FTIR spectra, you can see C-double-O bond, yeah? But in your soft molecule, there are no C-double bond. How you can explain it? If I right understand. I understand. FTIR, yeah. It's small, but it still is this, and you also mentioned about it.
Yeah, it is small. Maybe it is from the absorption of oxygen from the air, maybe, but
air is another.
I don't mean double.
CO double. Yeah, but the third one is small.
can be a fingerprint from the terephthalate dafite, because in that structure it has a CO bond.
So it's some initial product can stay in your.
Yeah, yeah, because actually here we can see that a triazine rings successful formation, and this small peak can be presence of the terephthalate, because we can see in the structure, it has like rounds.
Open that page. Sorry, corpse synthesize. It's clearly visible there. Can you open that corpse synthesize page? But the chemical is chemical formula. Okay.
What is double bond?
No, it's actually it's there. Didn't see it.
Initial product.
Yeah, it's not the initial, but it's your phthalic acid into this. See, there's
Yeah,
it's still there.
And here should be double bond as well.
Yeah.
Yes,
Yes.
aromatic double bond should.
Yeah, it's okay. Yeah, might wrongly labeled maybe.
It is what is detectable.
But in elemental analysis, you cannot see all oxygen. Also, that's why I question that. There are no oxygen.
yes, yeah. Elemental analysis.
Maybe it's labeled not properly. Maybe it's aromatic.
Yeah,
bond. Yeah, it's most.
Thank you for your question.
That's all. Thank you.
The remarks of the dissertation council. Are you satisfied with the answer of the candidate?
Yes.
Yes. Please. By Rashid Baba.
We can hear you.
Please, while Rashid Baba, repeat. Экран.
Sorry, we can hear you. Can you repeat your question? Yes.
For your question about diffusion of materials according to the second provision.
Коэффициент диффузии.
Yeah, we calculated. I wanna show to you the formula, what we used here on this. Yeah, thank you for your question. We calculate the diffusion apparatus according to this formula, and the values was obtained from the EIS data. And because we cannot provide directly diffusion work, that's why we manually calculate it. And by formula, it gives us like that values, and reviewers accept it, and we published in our research articles. There is already written like that. Thank you for your question. Yeah. Yes. By SARD-Z, we obtain one broad peak, and according to the literature data, it is related to the amorphous structure of this material. Like organic polymers. By the literature data and methods, what we synthesized and confirmed by the another XPS elemental analysis, instrumental analysis, we confirm that it belongs to the covalent organic frameworks materials, and present it like that in our research. Thank you for your valuable question. Also for the CV analysis, we calculated DFT analysis, and by theoretical calculation, this result is matched. And there is by CALFAL and EIS analysis also was investigated the charge transfer kinetics. We fitted these graphs, and all the obtained values show to us high value in comparison of just liquid electrolytes. And by the we investigated the photovoltaic performance of these materials, and like for the double confirmation of the perceived current density, we provided IPC analysis, and for the VOC we provided VOC analysis. And by all this instrumental analysis, we can see that in case of when we add coffee to the liquid electrolyte, it works better. And what is the main goal? It helps to prevent leakage and evaporation of liquid electrolytes. For the 40 days we tested. And also we tested under indoor condition under lab lamp, which it also shows the comparable results. Yes, and right in our article that the surface area and the pore channels to help of materials absorb more iodine and electron species and improve the ionic conductivity. So electrons can flow faster in case of this quasi-solid electrolytes and in general improves their efficiency and stability. Thank you for your valuable question. When we work on the optimization of these devices, we try different amount of this material. And when we increase the amount of this material, it is solidified. When, in case of 50 milligrams, it should be in our supporting information of our article. There is like the continuous of this table. In case of 50 milligrams, it is really totally solid. Inside of between two electrodes, there is only solid. And getting more solidified is transfer electron flow was poor and cannot work. Also for the stability, and only in case of more than 10 milligrams of the amount of those materials can work better. This is our findings. Yeah. Yeah, actually, it was a question of the time and funding. For that moment, we decided just for now take inside of Republic of Kazakhstan. Then after evaluation of time, maybe it will be necessary, we can go further. Thank you for your questions. Well, Rashid, are you satisfied with the answer? Okay. Please, Marjan Abdujabbarovna.
Қайырлы күн әріптестер, қайырлы күн диссертациялық кеңес төрайымы. Мен естіліп тұрмын ба?
Я естіліп тұрсыз.
Менде бүгінгі Аягоздың жұмысы бойынша бірнеше сұрақтар бар. 14-ші презентацияға бара қойсаңыз. Осы жерде сіз мына екі заттың тиімділігін қарастырған екенсіз. Биыл 125 затыңыз тиімділігі жоғары деп көрсетіпсіз. Бұл процесс электролиттің химиялық тұрақтылығымен қаншалықты байланысты? Сіздің затыңыздың электролиттік тұрақтылығы, химиялық тұрақтылығы электролитіңіздің қаншалықты жоғары?
Сұрағыңызды, иә, сұрағыңызға рахмет. Мұнда біз әртүрлі лакс бере отырып, құрылғыларды тексерген болатынбыз. Біз осы 1200 сағат бойы, бұл бізде 50 күн, күнде бір уақытта, бірдей лабораториялық жағдайда тексеріп отырған болатынбыз. Содан кейін осындай график құрастырылып, осы график арқылы жаңағы квазиқатты күйдегі электролиттердің 50 күн ішінде қатты төмендемегенін, оның фотоволтаика қасиеттері төмендемегенін айта аламыз. Ал сол уақыттың ішінде сұйық электролит төмен құлдырап, төмен бізге фотоволтаик қасиеттерін көрсеткен болатын.
Сонда сіздің екінші затыңыз химиялық тұрақтырақ болып тұр ғой, біріншіге қарағанда, иә?
Иә, өйткені ол квази қатты күйдегі электролит болып табылады.
18-ші презентацияны аша қойыңыз. Бұл жерде әртүрлі әдістерді қосып бірге берген екенсіз. Осы жерде XR дей тұр, иә, бірінші. Затыңыз қаншалықты аморфты, қаншалықты кристалды? Сіздің мына коф материалын қосқандағы затыңыз, қандай зат болды?
Бұл зат бізде аморфты. Негізі коф материалдар 2D, 3D форматтарға ие. Біздің синтездеген коф жаңағы структурасы бойынша, және де қабат қатпарлары орналасуы бойынша 2D модельге сәйкес келді. Біз оны өзіміздің мақаламызда жазып көрсетіп кеткен болатынбыз. XRD арқылы оның жаңағы аморфты күйдегі екені деп көрсеттік, деп дәлелдедік.
Аморфты, XRD аморфты екенін дәлелдеп тұр. Осы презентацияңыз бойынша тағы бір сұрақ. Термиялық тұрақтылығын қарап отырсыз ғой, үшінші суретіңізде. Осы термиялық тұрақтылығы практикалық қолдану үшін қаншалықты жеткілікті? Шегі қандай практикалық қолдануда термиялық, немесе ең төмен шегі қандай, сіздікі қай деңгейде?
Термиялық анализ 30 градустан 800 градусқа аралығында тексерілген болатын бұл материал. Сонда біз оның 400 градус аймағында жаңағы органикалық қаңқаның бұзылуын мұнда жаңағы 200 бен 445 температура аралығында негізгі органикалық қаңқаның ыдырауын көреміз. Одан кейін ол органикалық зат болғандықтан толығымен ыдырауға ұшырайды. Бізде бұл құрылғылар кең масштабқа, жаңағы далада, күн панельдері қолдануға да мүмкіндігі ие болғандықтан біз оның қаншалықты температураға шыдамды екен көру мақсатында осы термиялық анализді түсірген болатынбыз.
Рахмет. 19-ші презентацияға барсаңыз. Осы жерде сіз енді жалпы электрохимиялық қасиеттерін қарап отырсыз ғой, Осы жердегі электр өткізгіштігі мына сіздің коф материалын қостыңыз ғой. Коф материалын қосқандағы сіздің затыңыздың ион өткізгіштігі артты ма, әлде заряд рекомендациясын төмендеуі байқалды ма? Қай фактор басымырақ болып тұр сізде?
Оны біз тафл анализі арқылы көре аламыз. Екі бірдей платина электродтың арасында сұйық электролит және квазикатты күйдегі электролиттарды жинаған болатынбыз. Екеуіне бірдей тафл анализ жүргіздік. Сонда оригинда фитинг жасап, осындай график құрастырған болатынбыз. Мұнда бізде анод және катод слоп, анод, катод сызықтарын береді. Ол және де exchange current density, айнымалы ток анықталған болатын. Сол жерде егер жалпы сұйық электролитта G0-дің мәні 0,95 болса, коф қосқан кезде оның мәні 1,14 болған. Осы екеуінің сандық мәндеріне қарай отырып, біз электронның тасымалы осы сұйық электролитпен коф бойынша жасалынған құрылғыда электрондардың айналымы тезірек жүретінін байқадық, кинетикасын. Сондықтан ол тезірек электрондарды өткіздіргендіктен бізге жақсырақ ненің
яғни ион өткізгіштікті арттырады дейсіз ғой, қасиет, иә? Кофты қосқан кезде.
Тезірек жұмыс істейді. Триадит иондарын, иодид иондарына тезірек сындандырып отыр.
Соңғы сұрақ енді жалпы диссертацияңыз бойынша сіз нәтижеңізде айтасыз да, энергияның түрлендіру тиімділігін 25-9%-дан 27-4%-ға дейін жеткізгенсіз жұмысыңыз бойынша да. Бұл енді жұмысыңыз қолданбалы ғой, практикалық жұмыс. Осы бағытта мына 25-9-да 27-4% есептейтін болсақ, сол 1-4%-ға дейін, 1-3%-ға дейін аралықта тиімділікті байқағансыз. Осы практикалық маңызды болу үшін сіздің затыңыз, осы проценттік көрсеткіш жеткілікті ме? Коммерциализация үшін кейін мүмкін, жұмысыңызда.
Сұрағыңызға рахмет. Бұл жерде біз негізінде осы күн бояғыштармен сенсибилизацияланған күн элементтерінің басқа күн элементтерінен айырмашылығы, оның қараңғы жай ғана осындай жарық лампа арқылы жарықты көбірек сіңіре алуында. Және сондықтан көбірек бізге эффективті жұмыс жасайды. Мұнда біз жақшаның ішінде 27-37 деп көрсеттік. Ол 9 күн элементтерінің ішінде ең қатты жоғары максималды берген несі көрсеткіші, ал орташа мәні 25-74 болған. Енді егер де оны практикалық қолдану үшін, ол бізде бұл лабораториялық прототип болып саналады, лабораторияда жиналған, ал практикада қолданысын білу үшін мүмкін басқа бір үлкен масштабтағы материалдармен жұмыс істеп көру керек болатын шығар.
Рахмет жауабыңызға. Енді осы 1% көрсеткіш қолданбалылық үшін жеткілікті ме деген сұрақ еді ғой. Енді сіз 2 жоба бойынша қатыстым деп жатырсыз, жұмысыңыз 2 жоба бойынша гранттық қаржыландырумен қолдау тапқан екен. Ол 2 жұмыс аяқталған жұмыс па? Сіздің үлесіңіз қаншалықты болды осы зерттеу барысында? Сіздің зерттеу жұмысыңыздың үлесі қаншалықты бұл жобаларда? Және келесі осыған қатысты сұрақ, енді қолданбалы болғандықтан сіз енді осы жұмысыңызды ары қарай коммерциализацияға лабораторияда жасадым деп отырсыз ғой, енді практикалық өндірісте қолдануға ұсынып жатырсыз ба?
Сұрағыңызға рахмет. Әзірше біз мақалалар жариялаумен және патент алумен шектеліп отырмыз. Алдағы уақытта біз жаңағы айтқандай қатты күйдегі электролиттармен жұмыстар жалғасып жатқан соң, осы жұмыстардың жалғасы сол алдағы жаңа проекттерде жалғасын табады деп сенемін. Және де
ол жобалар қолданбалы ме еді?
Ол жобалар фундаменталды. Осы жылы аяқталып жатыр екеуі де. Осы 2 зерттеу және 1 әдебиеттік шолу жұмыстары осы проект бойынша жарияланған болады. Ол жақта мен ғылыми қызметкер болып жұмыс жасадым, қазір де жұмыс жасап жатырмын осы проекттер аясында, және осындай мақалалар жариялады.
Қолданбалы болу үшін ұсынасыз ғой нәтижелеріңізде болашақта?
Ғылыми жетекшімен ақылдасып, алдағы уақытта көреміз.
Рахмет жауабыңызға. Менде басқа сұрақ жоқ. Сәттілік.
Ажан Абдыжаппарова, сұраққа қанағаттандыңыз ба?
Иә, жақсы. Рахмет жауабына.
Please, Нәжіп қызы Меруерт.
Good afternoon, dear members of Dissertation Council. I have two more questions. Thank you for presentation. I want to see next slide, number 21, please. Since FF is almost unchanged, does it suggest that series resistance and interfacial charge extraction are not significantly affected by COF?
Thank you for the question. This is FF gives to us internal resistance of these materials to the general devices. Yeah, and we can see that during 50 days it is stable, and there is actually in case of quasi-salt electrolyte we can able to suppress recombinations, and by the EIS obtained resistance of recombination was lower in case of quasi-salt electrolytes. Here, the degradation of overall power conversion efficiency caused by the short course current density.
Thank you. Next question. What do you attribute the main contribution of COF to the efficiency improvement, to enhanced charge generation or suppressed recombination?
Thank you for this question. I think that it is help to us in both cases. In general, what helps us, it works as a scaffold and prevents the leakage and reduce charge transfer resistance. And by the shuffle analysis, we can say that it was by the higher exchange current density, there was a faster periodite, reduced iodide was faster, and COF materials help to us suppress recombination in general.
Thank you. Thank you.
Thank you.
Нәжіп қызы Меруерт, are you satisfied with the answer?
Yes, thank you very much.
Thank you. Are there any further questions? Or is it enough? Now, we will move on to the next stage of the Dissertation Council's work. The floor is given to the first official reviewer, Жексенбек Тоқтарбаев. Please, Жексенбек Тоқтарбаев.
Okay, thank you very much. I'm the official external reviewers of Ибраевои Аягоз. My comments on the stamped and signed version was already submitted to the board. So here, let me read the most important part of the comment. Ибраевои Аягоз Каи, the thesis entitled Design of Highly Effective Novel Electrolytes for Photovoltaic Application, submitted for the degree of Doctor of Philosophy in Education Program 8D05306 Chemistry. Section 1. The correspondence to the priority areas of science development of our program. This work was funded by the Science Committee of the Ministry of Science and Higher Education of Republic of Kazakhstan, grant number AP23490505, indoor photovoltaics based on the dye-synthesized solar cells of advanced architectures, priority area, energy, advanced materials, and the transportation. And the sub-priority was alternative energy. The second grant was AP1487056 development of low-cost bifacial indoor dye-synthesized photovoltaics for a sustainable Internet of Things. Priority area energy, mechanical engineering. Sub-priority area was alternative energy and technologies. And has this work a significant contribution to the science? Yes, this research work is scientifically contribution to the science, and its significance is clearly demonstrated. And the published review and the research articles improved understanding of how molecular design and electrolyte engineering can enhance the efficiency, stability, and durability of dye-synthesized solar cells. And the level of independence is high. The work demonstrates a high degree of independence and originality in both conceptual development and experimental execution. These contributions indicate that the PhD candidate was primarily responsible for formulating the research objects, designing methodologies, conducting experiments, analyzing, interpreting data, preparing manuscripts for the publication. The candidate published 3 publications indicated here. And justifications of the relevance of dissertation is fully justified. The relevance of the work presented work is well founded and comprehensively justified by the pressing global demand for efficient, stable, and economically viable energy solutions. In particular, the development of the durable and high-performance electrolytes represent a critical challenge in advancing next-generation photovoltaic technologies. The contents of dissertation reflects the dissertation topics are fully reflected. The content of the research work is fully aligned with the stated topic and provides the comprehensive examination of the scientific problem related to the development of high-performance electrolytes. The purpose and objectives correspond to the research topic. The aim and objectives of the research work are fully aligned with its central topic and articulated in clear, coherent, and logically structured manner. Section 5, the principle of the scientific novelty. The scientific results and provisions are completely new. All scientific results and provisions are fully original and represent novel contribution to the chemistry and the material science, engineering, stability, electrolytes of covalent organic frameworks to boost the dye-synthesized solar cell efficiency. That work was published in Article 1. The novelty of this work lies in the development of COF engineered liquid electrolyte system, where the COF functions as the porous and the host matrix for the redox species. This approach transforms the conventional electrolyte into structurally organized multifunctional medium, enabling the simultaneously enhancement for the ionic transfer, interfacial charge transfer, and the long-term stability. Enhancing the stability and the efficiency of dye-synthesized solar cells with MIL-125 metal organic frameworks as electrolyte additives. This results was published in Article 2. The integration of the MIL-125 metal organic framework into a liquid electrolyte to form a constructed metal organic framework electrolyte hybrid system is a novelty of this work. The approach enables the simultaneous control of ionic transfer, charge recombination, and the electrolyte stability, effectively bridging the gap between the liquid and the quasi-solid architectural. the quasi-solid electrolytes architecture while maintaining the high photovoltaic performance, particularly under indoor illuminations. The advancement in carbazole-based synthesized and whole transport materials for enhanced photovoltaic performance was published in Article 3. The novelty of this review article in the comprehensive and integrative analysis of carbazole-based materials in both dye-synthesized and whole transporting components in VSSCS. Unlike conventional review that this treats these elements separately, and this study establishes a unified structure property performance relationship, providing the design insights for the development of efficient, stable, and cost-effective photovoltaic system. The section 5.2 are the dissertation conclusions new. Yes, that the research work conclusions are grounded in advanced electrochemical techniques and presented the original scientific contributions to the field. The findings have been communicated through the publications with reputable high impact factor in international journals. The 5.3 is technical and technological, economical solutions are justified or new. The technical, technological, and economical aspects of the findings demonstrated the varying degree of novelty, with the particular notable innovations and reflected in the published papers. Section 6, justification of the main conclusions. All main conclusions based on the scientifically sound evidence and are sufficiently justified for the qualitative research and the disciplines in the arts and humanities. All key conclusions are based on the scientifically sound and the evidence and adequately supported with the relevant qualitative research framework. Section 7, the main provisions submitted to defense. Provision 1 is approved. It has been shown that the use of carbazole derivatives for the synthesis of small organic molecules enables the formation of novel structure with the potentially high functional properties suitable for application as a whole transporting materials and electrolytes. Based on the first provision, one paper is published in the molecules. And the provision 2 has been demonstrated that the incorporation of MIL-125 into iodide 3-iodide solid state electrolyte increases the power conversion efficiency from 9.14% to 10.51%, enhance the short circuit current density, and reduce the charge transfer resistance. And based on the provision 2, also published one paper in the scientific reports. And the provision 3 is also proven, and it has been established that the addition of triazine-based covalent organic frameworks to the liquid electrolyte increase the power conversion efficiency from 8.87% to 10.88%, improve the short circuit current density, and reduce the charge transfer resistance, enhance ionic conductivity, and diffusion coefficient. And based on this provision 3, also one paper was published in the Matters to the Energy in 2025. Section 8. Research methodology is justified or the methodology described clearly. The research methodology is clearly justified and described with the sufficient clarity and detail, ensuring the reliability and reproducibility and viability of the obtained work. And the results of the dissertation were obtained using the modern scientific research methods like XRT or TGA or thermogravimetric analysis, X-rays of the electron spectroscopy, and electron microscopy like SEM and TM, NMR analysis. Section 9. The dissertation has a theoretical significance. Yes, dissertation has a theoretical significance. This work lies in advancing and understanding the electrolyte functionality in dye-synthesized solar cells through the introduction of structurally engineered materials such as the covalent organic frameworks and the metal organic frameworks. And these studies demonstrate that electrolyte behavior can be modulated via host-gas interactions and the controlled porosity, and thereby extending the conventional diffusion-based model over nanostructured transport system. And the practical significance of the dissertation, the practical significance of the work. The conducted work demonstrated substantial practical significance and high potential for the implementation of in the field of photovoltaic energy conversion. The proposed approach, including the incorporation of metal organic frameworks and the covalent organic frameworks, based materials, as well as carbazole-derived whole transporting system, effectively address the key limitations of conventional dye-synthesized solar cells, such as electrolyte instability and the charge recombination and the limited operational durability. Nevertheless, so I have here 2 questions. The first question is what are the key role of electrolyte in DSSCs beyond the simple charge? And the second question, a similar question was also asked during the presentation, and here the second one. So why the traditional iodine and iodide 3 redox couple is still dominant despite its limitations? Okay, my comments over, and so please, I have 2 questions.
Thank you for your valuable presentation.
Candidate Aягоз Kаи, please respond to the comments of the first.
Thank you for your questions. Regarding to the first question, electrolyte has different roles in dye-synthesized solar cell. First of all, it should be fast regenerate oxidized dye. Secondly, it is a charge transport between photoanode and photocathode. And third one, it is controlling of recombination reactions. Also, it should be chemical and thermal stable. And design of electrolyte materials should be planned according to the also absorbing properties, such as electrolytes should not compete with the dye for the light absorption. And for the second question, beyond of the just iodide, triiodide redox couple, for now it is developing a transition metals. It is a cobalt and copper redox pairs. They have these new materials also have their own advantages and disadvantages. Advantages that they have it can be more efficient, but the problem is their stability and high recombination. That's why these new materials also bring with them new challenges to the researchers. That's why we use iodide-triiodide redox pair as a standard, which is a well-established. We know this chemistry, and so many research was done with this redox couple, and it is improved in general by his nature, ionic conductivity, and has less recombination and can be able to regenerate dyes faster. Also, what is good in iodide redox pairs that they can match with broad class of the dyes, unless other redox pairs.
Okay, so what was the limitation of this couple?
Iodide
Yes.
or other analogs like
No, iodide and triiodide.
The limitation is the leakage and evaporation time by time. That's why we are looking for the materials which can help to improve the general performance of these devices and can be degraded.
Okay, so despite on that limitation, but still used a lot.
Yeah.
Okay. So
Are you satisfied with the answer?
yes, that's good. So I'm satisfied. So let me finish my comments. So to conclude my comments, so I have read all the Ibraevos publications, and all publications are very good. It's Scopes and the Web of Science publication. She has published 3 papers and in very good journals. And all the research work and the experimental design and the novelty, the scientific contributions of the work is very nice. So my comment is, so Aягоz Ибраевои is fully qualified for the PhD of his field education program of 8T 05 and 07. That's all I support.
Are there any questions to the official reviewer of the candidate? If there are no questions, then the floor is given to the second official reviewer, Merve Najibkızı. Please, Merve Najibkızı.
Thank you. Let me read the review of the work. Review of the official reviewer for the dissertation work of Ибраевои Аягоз Каи entitled Design of Highly Effective Novel Electrolytes for Photovoltaic Application, submitted for the degree of Doctor of Philosophy, PhD, in the educational program 8D05 306 Chemistry. There is criteria. First, the dissertation topic aligns with the directions of the science development and government's programs. The dissertation corresponds to a priority area of science development approved by the Higher Scientific and Technical Commission under the government of the Republic of Kazakhstan. The dissertation work is presented in the form of a series of articles published in accordance with the requirement of Clause 5.1 of the rules for awarding degrees and was provided according to the projects of Science Committee of the Ministry of Science and Higher Education of the Republic of Kazakhstan, grant number AP 234-90505, indoor photovoltaics based on solid-state dye-synthesized solar cells of advanced architecture, priority area energy, advanced materials and transportation, by sub-priority alternative energy, and also second project AP 148-70560, development of low-cost bifacial indoor dye-synthesized photovoltaic for sustainable Internet of Things application, priority area energy and mechanical engineering, by sub-priority alternative energy and technologies, renewable energy sources, nuclear and hydrogen energy, and other energy sources. Second, importance for the science. The work makes a significant contribution to science, and its significance is clearly confirmed. The principle of the independence is high. The dissertant is the first author in 3 articles for the PhD degree, which I noted in my review with their DOI. The principle of the internal unity fully justified. The dissertation is relevant and fully justifies the development of stable, high-performance and cost-effective electrolytes for sustainable solar devices represents an urgent scientific and technological challenge that this dissertation addresses. The study supports the global effort to make solar energy a valuable energy source across a range of applications, from low-light indoor systems to outdoor solar panels, and a competitive alternative to fossil fuels. Next, content of the dissertation reflects the dissertation topic. Yes, fully reflects. The content of the dissertation fully corresponds to the stated topic and addresses the scientific problem of developing highly efficient electrolytes based on materials that prevent leakage and evaporation of liquid components. Next, the purpose and objectives correspond to the dissertation topic. The aim and objectives of the dissertation correspond to the topic and are formulated clearly and logically. The research plan was developed in line with the stated aim, and all objectives were completed. No inconsistencies were found between the dissertation topic and its aims and objectives. All sections and provisions are logically interconnected. Yes, all sections and provisions are logically interconnected. Next, the novel solutions proposed by the author are substantiated and critically assessed in comparison with known solution. A critical analysis is provided. The results and conclusions presented in this dissertation are scientifically justified. All obtained data are supported by sufficient evidence. Critical analysis was applied to evaluate the literature and compare the results with previously published studies. Next, the principle of the scientific novelty. Five criteria. Are the scientific results and provisions new? Yes, completely new. All scientific results are original and represent novel contributions to material chemistry. There is articles, engineering stable electrolytes with covalent organic frameworks to boost dye-sensitized solar cell efficiency. This is first article. This work demonstrates for the first time the application of a trizane-based covalent organic framework as a functional additive to liquid electrolytes in dye-sensitized solar cells. Second article, enhancing the stability and efficiency of dye-sensitized solar cells with MIL 125 metal organic framework as an electrolyte additive. The use of metal organic framework as an additive to an iodide, triodide-based liquid electrolyte to form quasi-solid electrolytes represents an innovative approach that significantly improves the photovoltaic performance of DSSCs. Third article is advancement in carbazole-based sensitizers and whole transport materials for enhanced photovoltaic performance. This study provides a comparison of their photovoltaic efficiencies with benchmark dyes such as ruthenium-based N719, highlighting the role of carbazole derivatives as promising metal-free alternatives. It also summarized carbazole-based structure as whole transporting materials. Next, 5.2, are the dissertation conclusions new? The conclusions of dissertation are based on advanced electrochemical methods and represent novel scientific contributions to the field. The results have been published in high-impact, peer-reviewed international journals. 7.3, technical and technological, economic or managerial solutions are new and justified. Yes, completely new. Overall, the technical, technological, economic, or management decisions in the dissertation findings vary in their novelty, with significant innovations particularly evident in articles. Due to the lack of detailed information about the economic side of the proposed technological solution published in the articles, it is not possible to draw any conclusions. 6. Justification of the main conclusion. All main conclusions are supported by solid scientific evidence and are sufficiently justified within the framework of qualitative research approaches where applicable. The results are based on advanced instrumental characterization and electrochemical analysis, which ensures their reliability and reproducibility. In addition, the publication of these findings in high-impact peer-reviewed international journals, as well as their presentation at reputable international conferences, confirms their scientific validity and relevance of to current developments in chemistry. 7. Main provisions submitted for the defense. It is necessary to answer the following questions for each provision separately. So, provision 1, first, it has been shown that the use of carbazole derivatives for the synthesis of small organic molecules enables the formation of novel structures with potentially high functional properties suitable for application as whole transporting materials and electrolytes. Based on critical analysis of the literature, the use of carbazole in the synthesis of small organic compounds is justified as a promising yet insufficiently explored approach, opening new opportunities for the development of functional materials for photoelectrochemical application. 7.1 is the provision proven? Yes, proven. 7.2 is the provision results trivial? No, not trivial. 7.3 is a provision new? Yes, this provision for defense is characterized with scientific novelty. 7.4 level of applicability. Wide. 7.5 as a provision supported by publications. Yes, proven in the article. This principle is proven in the following articles: advancement in carbazole-based sensitizers and whole transport materials for enhanced photovoltaic performance, journal Molecules, volume 29, article number 5035. And next provision, next provision, second provision, it has been demonstrated that the incorporation of MIL 125 into an iodide triodide quasi-solid state electrolyte increases the power conversion efficiency from 9.14% to 10.51%, enhances the short circuit current density from 18.01 to 20.97 milliamps per square centimeter, reduces charge transfer resistance from 1.79 to 1.99 ohms, increases ionic conductivity, millisiemens per centimeter, 3.336 to 3.02, and ensures stable operation for 60 days while achieving 25.9% PCE under low light illumination, 6000 lux. According to provision 2, 7.1 is the provision proven? Yes, proven. 7.2 is the provision result trivial? No, not trivial. 7.3 is the provision new? Yes. This provision for defense is characterized by high degree of scientific novelty with filling gap in the research using MOFs as framework to prevent leakage, liquid electrolytes. 7.4 level of applicability, wide. 7.5 are the provisions supported by publications. Proven in the article, this principle is proven in the following articles: enhancing the stability and efficiency of dye-sensitized solar cells with MIL 125 metal organic framework as an electrolyte additive. Journal Scientific Reports 2025, volume 15, article number 5883. 7.6, no, sorry, provision number 3. And also there are other several articles, conferences, materials enhancing dye-sensitized solar cells efficiency and stability with titanium MOF-based quasi-solid state electrolytes, 12th International Conferences on Nanomaterials and Advanced Energy Storage Systems, INES, 2024, Astana, Nazarbayev University. Also, MOF-based electrolytes, a paradigm shift in enhancing the efficiency and stability of DSSCs. Also, annual research conference, Astana, Nazarbayev University, 2024. And next conferences dedicated to the anniversary of Academician Buketov, Karaganda, 2025. Title of topic: Metal Organic Frameworks and Covalent Organic Frameworks as Electrolyte Enhanced, a pathway to high efficiency and stable DSSC. Silk Road Chemistry, Modern Chemistry Technologies and Science, collection of abstracts of the first international scientific and practical conferences dedicated to anniversary of Academician Buketov. Provision number 3. Provision 3, it has been established that the addition of a triazine-based covalent organic framework to the liquid electrolyte increases the power conversion efficiency from 8.87% to 10.81%, improves the short circuit current density from 15.85 to 18.16 milliampere centimeter minus 2, reduces charge transfer resistance from 3.0 versus 5.5 ohms, enhances ionic conductivity from 2.01 to 1.11, and the apparent diffusion coefficient 7.54 to 3.2 10 minus 16 centimeter square S-1, and maintains operational stability for 40 days with PCA of 27.4% under low light condition 6000 lux. 7.1 is the provision proven, yes, proven. 7.2 is the provision result trivial, no, not trivial. 7.3 is the provision new. Yes, this provision for defense is characterized by a high degree of scientific novelty. 7.4 level of applicability, wide. 7.5 as a provision supported by publications. Proven in the article. This principle is proven in the following article and utility model patent of Republic of Kazakhstan. Authors Aягоз Ибраева, Diana Suleimenova, Zulfiya Imambekova, Urker Abibullah, Bakhjan Babtayev, Manix Balanay. Engineering stable electrolytes with covalent organic frameworks to boost dye-synthesized solar cell efficiency. Materials Today Energy, 2025, volume 54, article number 102088. And also method of improving stability and efficiency of dye-synthesized solar cells. This is patent number 11169 from 2025, 19th of December. And another publication is the 4th International Symposium of Emerging Materials and Devices, Astana, Nazarbayev University, National Laboratory, Astana, 2025. Publication topic, a new avenue for enhancing DSSC performance using covalent organic frameworks in electrolytes. And next, also, this is a conference meeting, national meeting, Washington, USA, 2025. Covalent organic frameworks as electrolyte enhances a pathway to high efficiency DSSCs. Presented by Ибраева, Сулейменова, Иманбекова, Абибулlah, and Babtaev and Palani. Next, 8. The principle of reliability. Yes, research methodology is justified or methodology is described clearly enough. Yes, all applied synthesis methods are comprehensively described in the reference articles and detailed in the experimental section of this work, thereby ensuring the reproducibility of the obtained results. 8.2. The results of the dissertation were obtained using modern scientific research methods and techniques for data processing and interpretation with the use of computer technologies. Yes, the results of the dissertation were obtained using advanced scientific research methods and state-of-the-art characterization techniques for the synthesized materials. This included scanning electron microscopy, transmission electron microscopy, energy dispersive X-ray spectroscopy, X-ray diffraction, thermogravimetric analysis, nitrogen absorption-desorption analysis, X-ray photoelectron spectroscopy, Fourier transport infrared spectroscopy, nuclear magnetic resonance, Raman spectroscopy, and UV visible spectroscopy. In addition, density functional theory calculations were used to investigate covalent organic framework materials. Data analysis and visualization were performed using specialized software, including PalmSense, Origin, ImageG, ChemDraw, and Inkscape. 8.3. Theoretical conclusions, models, identified relationships and patterns are proven and confirmed by experimental research. Yes, the theoretical conclusions, proposed models, and the identified relationships and patterns are rigorously substantiated and validated through experimental investigations. 8.4. Important statement and confirmed by reference to relevant and reliable scientific literature. 8.5. The used literature source are sufficient. Are sufficient for the literature review. The literature sources employed are sufficient and appropriate for conducting comprehensive and well-founded research and literature review. 9 criteria. The principle of the practical value. 9.1. The dissertation has theoretical significance. Yes, the dissertation provides a theoretical framework for understanding charge transfer and ion transport processes in DSSCs, modified with porous framework materials. It improves our understanding of charge transfer, energy level alignment, and donor P-acceptor interactions in organic semiconductors. These findings contribute to materials chemistry, electrochemistry, and photovoltaic science by establishing molecular design principles for next-generation sensitizers and charge transport layers. 9.2. The dissertation has practical significance and there is a high probability that the results obtained can be applied in practice. Yes, this dissertation work provides a scalable method for creating stable, high-efficiency DSSC using electrolytes based on CoV and MOV. The resulting materials are attractive candidates for next-generation photovoltaic technologies and self-powered electronic systems because they exhibit cheap production costs, long-term operational stability, and exceptional light harvesting performance in both indoor and outdoor conditions. 9.3 Practical recommendations are new. The practical recommendations proposed in the study are entirely novel. The dissertation findings are supported by 3 peer-reviewed articles published in Scopus and Web of Science indexed journals and by 1 utility model patent registered in the Republic of Kazakhstan. 10. Quality of writing and formatting. The academic writing is high, characterized by clarity and conciseness, and all research aspects are articulated using contemporary scientific language. 11. Reviewer comment on the dissertation. The dissertation is well structured and presents significant scientific results in the field of photovoltaic materials. The study demonstrates a high level of originality and strong experimental methodology. The work would be further strengthened by a more detailed discussion of the practical implementation of the development electrolytes, particularly with respect to their scalability and potential industrial applications, as well as their performance under long-term environmental conditions. Last comment, it would also be beneficial to include a more explicit comparison with state-of-the-art photovoltaic materials and technologies in order to further highlight the advantages and novelty of the proposed approach. 12. Scientific level of the PhD students' articles on the research topic. The published articles demonstrate a high level of scientific rigor and highlight the international significance of the obtained results. These findings have been further validated through presentations at international scientific conferences, as well as through the granting of a utility model patent in the Republic of Kazakhstan. Moreover, the submitted manuscripts have undergone independent peer review in international journals, confirming the scientific soundness and credibility of the reported results. Finally, 13. The decision of the official reviewer according to clause 28 of the present standard regulation. Based on the aforementioned findings, I recommend awarding the degree of Doctor of Philosophy to Ибраевои Аягоз Каи according to the educational program 8D05-306 Chemistry for her dissertation work titled Design of Highly Effective Novel Electrolytes for Photovoltaic Application and for developing of understanding metal organic framework and covalent organic framework and investigating liquid electrolytes issues in dye-sensitized solar cells by enhancing photovoltaic performance. All publications have been published in high-ranking journals. I wish Aягоз continued success in her future endeavors. Thank you, reviewer PhD candidate of chemical science and professor Al-Farabi Kazakh National University, Meruyet Najibkızı. Thank you for your attention.
Meruyet Najibkızı, candidate Aягоз Kаи, please respond to the comments of the second review.
Thank you for your valuable questions. According to the first question, it was about the scalability and next-sized solar cells. This class of photovoltaic technology has a big potential for the scalability because next-sized solar cell can be fabricated through the roll-to-roll screen printing and other processing techniques. But there is a limitation, such as evaporation of liquid electrolytes. That's why our research is working on the improved these liquid electrolytes with adding advanced materials like more materials. And for the second question, in the third generation of photovoltaic technology, there is organic solar cells, perovskite solar cells also developed nowadays. The problem with these organic and perovskite solar cells, they are especially perovskite solar cell has a big high efficiency, but the problem is that they used toxic like lead metals, rare and expensive metals. The problem is the toxicity with this solar cell and stability, because they can be only fabricated under glove box. And if I will compare with the organic solar cell, there is a low efficiency and also use toxic very expensive materials. That's why the solar cells stands out for the easy fabrication or low cost, because it can be used transition metals of them, and also can be applied on the flexible devices, Internet of Things, in the building integrated technologies, also in wearable devices. That's why the novelty of this research is extent of the understanding and improving the electrolytes in general, the solar cell, and give to one step to closer to develop these electrolytes.
Are you satisfied with the answer?
Actually, my comments for future, yeah, I'm satisfied. Yeah.
If there are enough questions, then we move on the next stage of the dissertation council, listening to the reviews of the scientific supervisors. First, the floor is given to the international supervisor, Robert J. O'Reilly.
With great pleasure, I am sending this letter of reference for Aягоз Ибраева, a PhD student at the University, who is under my academic supervision. Ms. Aягоz Ибраеva has continued her own academic excellence, great and sincere dedication to expanding scientific knowledge in the fields of chemistry, nanotechnology, and the renewable energy source during her PhD studies. During her doctoral studies, Aягоз Ибраева conducted significant research on the design and the development of various types of electrolytes, including quasi-solid state and solid-state electrolytes, with a particular focus on their application in photovoltaic systems, especially dew-sensitized solar cells. Her research has resulted in several publications in reputable scientific journals, reflecting those of quality, the quality and the impact of her work. During her candidate, she published the following articles, in which she is first author. Considering these achievements, I am confident that Ms. Aягоz Ибраева has fulfilled all the academic and the scientific requirements necessary for the successful defense of the doctoral dissertation. Therefore, I strongly recommend that Ms. Aягоz Ибраева be awarded the degree of Doctor of Philosophy PhD in the field of chemistry. Robert O'Reilly.
Thank you, Dr. Iparazi. Next, the floor is given to the board of the discussion, please.
Dear Chairman, dear members of the Dissertation Council, I would like to say a few words about the doctoral student, Ms. Aягоz Ибраева, and her dissertation work entitled Design of highly effective novel electrolytes for photovoltaic application. During her doctoral studies, Aягоz showed herself as a responsible, hardworking, and motivated researcher. She actively participated in the scientific discussions, independently carried out experimental work, and demonstrated good analytical and research skills. Her research is devoted to an important and modern research topic related to dye-synthesized solar cell, covalent organic frameworks, metal organic frameworks, and new electrolyte materials for photovoltaic applications. The obtained results showed good stability and efficiency of the developed systems. Also, during her PhD studies, Aягоz published articles in peer-reviewed international journals, including Q1 and Q2 journals, participated actively in the international conferences. This demonstrates that work has scientific value and relevance. In my opinion, the dissertation work meets the requirements for the PhD degree in chemistry, and Ибраевои Аягоз Каи deserves to be awarded the degree of Doctor of Philosophy. Finally, I also like to thank Professor Manis Valny, who provided the opportunity to carry out this work in his laboratory of functional materials and computational chemistry. Thank you.
Are there any questions for about the deputy? No. Now we move on the partner. Are there any comments on subject? You may speak. Are there any? This is on this work. I'll be very interested to hear the of the dissertation class. I would like to go with this very hot defense because it was a lot of questions and very good answers, and I think it's very high level work. Maybe it's not finished completely because we can see that some results in progress. And I think it will be finished the possible of your life. So I would like to this work was very nice, and of course should be supported by the council scientific dissertation council. I think it's very good work. Thank you. Here, colleagues, we have listened to the reviews of the official reviews, the scientific consultants, their activity. If there are speakers, then is all. Please allow me to give to the floor of the concluding remarks to the candidate Ибраевои Аягоз Каи. Thank you. So I would like to say big thanks to my scientific supervisor, to Dr. Ибраевои and Dr. Ибраевои for their scientific guidance throughout this PhD journey. So, since gratitude will go to the Professor Manis Valny, who warmly welcomed me to his research group and shared with his expertise, guidance, and give a lot of time to train and for his patient. Also, I would like to say big thanks to the Dr. Bakhtiar for his invaluable guidance and continuously support. Also, for the functional laboratory for the functional materials and computational chemistry at Nazarbayev University for their friendly collaborative atmosphere. And I also
would like to say big thanks to my family, to my close relatives who believe in me throughout this journey. And I would like to say thanks to the chemistry department, to the Institute of Natural Sciences, Women of Eurasian National University, and also the dissertation council chairman and members, also for reviewers, for their invaluable work and support. Thank you very much.
Thank you, Aягоз Khairullah. Now we must proceed to the next stage of the dissertation council, secret voting via the smart platform. For all other participants, a break is announced, and we ask you to move to the wait room. Only members of the dissertation council and reviewers remain for voting. All members of the dissertation council must determine the ballot whether the author of the degree Doctor of Philosophy under the education program AD 0506 chemistry. Secret voting will be conducted on the Smart Inno platform. Permanent members use their Platonus Inno login and password. Temporary members and reviewers will be sent login credentials. Dear members of the dissertation council and reviewer, you must choose one of the following options. Award the degree of Doctor of Philosophy, PhD, or Doctor by profile. Send the dissertation for revision. Send the dissertation for redefense. Refuse to award the degree of Doctor of Philosophy, PhD, or Doctor by profile. If everything is clear regarding voting, a break for secret voting is announced. The scientific secretary will now explain the process. Rullakızı, please. Voting has started. You may vote. Voting is complete. Results are displayed on the screen.
We can't see results on the screen.
Just one moment, please.
If everyone has voted, then the floor is given to the scientific secretary Tovjan Turgalikızı. The participants may now rejoin. Thank you. A total of 9 participants in the secret voting decided to award the degree of Doctor of Philosophy to Ибраевои Аягоз Каи. Now I ask to vote openly for the result of the secret voting. In favor all, against none, abstain none, unanimously. Congratulations to Aягоз Kаи. Congratulations to the supervisors. The dissertation in the form of a series of articles for the degree of Doctor of Philosophy PhD on the topic design of highly effective novel electrolytes, photovoltaic application in the specialty AD 05306 chemistry meets the requirements for awarding degrees of the Ministry of Science and Higher Education of the Republic of Kazakhstan. The author of the dissertation Ибраевои Аягоз Каи deserves to be the degree of philosophy PhD, the education 05306 chemistry. Let us proceed with the discussion of the draft conclusions. There remains one question. We must adopt the conclusion. The patient constitutes the patient work. The draft conclusion sent to you in advance via email. I hope you had time to review it. If there are no objections, we may adopt the draft as a basis. If there are comments or suggestions, please send them to the scientific secretary. We will take them into account and revise accordingly.
The main text, it's okay because we received it in advance, and all members of scientific council, maybe we can work for the last chapter of this conclusion about points, classification features of dissertation work.
So classification features of the dissertation, 8.1, nature of the dissertation result. 8.1.1, theoretical provisions, the sets of which can be qualified as a measure of your achievements in the development of the relevant scientific fields. Or 8.1.2, solution of scientific problems of significant social, cultural, economic, and political importance. Or 8.1.3 scientifically substantiated technical, economic, or technological solutions, the implementation of which makes a significant contribution to accelerating scientific and technological progress. 1.1.
8.1.
Everybody, I agree.
Yes.
Yes.
Next, 8.2, level of novelty of the dissertation results.
The results are novel, yes. Yeah, first.
Okay. Next, a value of the dissertation results. 8.3.
8.1.
High.
Next, connection of the dissertation topic with planned research. There are two projects, right?
Number 2 was the local projects, yes, not international.
Yeah.
Number 2.
Number 2, yeah.
8.5, a level of implementation, application of dissertation results with practical significance and recommendation for their wider use.
5.2.
Intersectoral level, right?
Yes. Because international level here should be.
Yeah, no international grants.
Yes, it's more.
So,
They are members of the dissertation council. If so, let us vote. In favor all, against none, abstain none, unanimously. Thank you. All agenda items have been exhausted. I would thank all members of the dissertation council and reviewers for their work and active participating. Goodbye. Равнее, thank you.
Bye.
До
Thank you.
свидания, спасибо. Равнее, как скандалится.
Congratulations.
Congratulations.
Правильно,